This video will introduce how you can discover and examine the states of water with young children. In other words, water in gas, liquid, and solid form. I will also explain how the molecule, the shape of the molecule, actually influences all the unique qualities of water. My name is Lisa Despon and I teach science in preschool at a university in southern Sweden. Children often have a lot of experiences with water through fun and games incorporating water in liquid or solid form. However, it doesn't necessarily mean that they understand why water changes states. It's not unusual to hear children say that they want to bring a snowball inside to keep it for tomorrow. That could be a good start to work with the states of water as a scientific theme. You can bring the snowball inside, put it in a bowl, and have a discussion with the children about what they think might happen. The older age groups will probably have a good idea, but you can sometimes be surprised. Bring the snowball inside and evaluate the results the next day. Why did it turn into a puddle? Talk about the other times ice or snow melts or freezes. Sometimes water can freeze during cold nights, like water coming out of the ground making beautiful ice formations, like the girl is looking at in the picture. Or dew that turns into frost on a dry leaf. But why is there dew in the first place? The air can contain different maximum amounts of water depending on temperature. Warm air has the ability to hold more water vapor than cold air before it gets saturated. Saturation can also be referred to as 100% humidity. When the air temperature decreases at night, droplets will form on cold surfaces. Have you noticed how you can get condensation on an ice-cold drinking glass on a hot day? That's because the air around the glass becomes colder and thereby saturated. Small droplets can also form in the air as the humidity exceeds 100%, creating a fog or clouds in the sky. In a similar fashion, you can create your own clouds on a cold day with your breath, as it contains more water than the cold air can hold. You can show that your breath contains water even more clearly by breathing on a cold surface and watch the droplets form. The exhaust from planes also contain high humidity levels, which ends up as white streaks in the cold high altitudes. The properties of ice is also something which can be investigated. For example, why does ice form a layer on top of puddles? To answer that question correctly, we need to understand how the molecules are organized in the different states. The water molecules themselves don't change when the state of water changes, but their kinetic energy and distance between molecules and how they are positioned changes. When water forms ice, it creates almost like a crystal formation that leaves spaces in between molecules, as you can see on the right in the picture. They vibrate slightly, but there is no great movement. When water turns into a liquid, the movement increases. You can explain this as if they're floating around to get a visual picture. Even though they're moving around, there is less of a space between molecules, which is why liquid water has higher density than ice. This is why ice floats. Most other substances have highest density in solid form, which makes water quite unique. As you increase the temperature, the water starts moving more and more, and when it turns into vapor, the molecules are moving a lot and have larger distances between molecules. You can engage in play-based learning with the kids where you pretend to be water molecules. A water molecule looks like this with arms straight ahead. And when you're forming ice, you grab onto each other and vibrate slightly on the spot. And as the temperature increases, you let go of the hands and start moving around, shuffle around the room. And as the temperature increases, you start walking and then running around and try not to bump into each other. And you need more and more space in the room to do that. The reason for the crystal formations of ice is due to the polar properties of the water molecule. The larger atom, which is portrayed as a red in this illustration, is oxygen, and it's on average more negatively charged. The two hydrogen atoms are more positively charged. Because of the structure, one side will be more positive than the other, which makes the molecule polar. In this illustration, the molecule looks somewhat like a face of a cricket, but it's also sometimes illustrated as Mickey Mouse, which can be a good way for the kids to remember the structure. The structure of the molecule makes one side positive and the other negative, which creates temporary bonds between the molecules. You can see in this video how that could be illustrated. The polar properties of water influence our entire planet. If ice had a higher density than liquid water, it would sink to the bottom. That would influence the important currents and movements of water in both lakes and oceans. The strong polarity of water also influenced the temperatures needed to change states. Despite the small size of the molecule, it's a liquid at room temperatures, whereas other molecules of similar sizes are generally gases. As a comparison, for example, the temperature of oxygen needs to be minus 220 degrees centigrade to form a liquid. You can make standardized experiments with children where you try to establish what things melt ice. You can, for example, have glasses with an ice cube in each, and in the first one you have done nothing, so it's your control, it's just a piece of ice. And in the other one you can, for example, have water and an ice cube and salt water, and the white ice cube that you see in the picture is an ice cube made of salt water. And the children get to guess which one they think is going to melt first. And after you've made your predictions, you can then evaluate your hypothesis. And this is a really good way, especially if you document your hypothesis, because then the children will be able to go back and look at what they thought would happen, and then reason around what happened and form new hypotheses, and you can try it out in different ways. Children often have experiences of how salt affects snow or ice, as salt is sometimes added to roads and pedestrian areas to prevent accidents. The effects of salt can also be tested in different ways. At one point, a child asked if it's possible to freeze salt water. I was personally unsure if freezer temperatures would be cold enough. So we put saturated solution in the freezer, and the result was white ice, which looks more like frozen whipped cream. Salt water has a colder freezing point than fresh water, which is why you can melt water by adding salt. The reason why you get a salt water solution in the first place is because of the polar properties of water. Salt contains a positive and a negative ion that splits up in water and latches on to the negative and positive sides of the water molecule. Other polar substances can also mix with water in a similar way. Sugar and alcohol are two polar substances that mix with water. Oil, on the other hand, is non-polar. That's why it doesn't mix well with water and forms a layer on top. If you wish to learn more about how to teach science in preschool, you can check out the other content on my channel. Until next time.